Hi, welcome to the Commercial Gas Engineer channel. Going to do a service here on this 45, or should I say 55 kilowatt boiler, a Keston, and if you want you can stay with me. I'm going to go through it from beginning to end and a few other little checks in the plant room, in the control panel, and what else I can fit in the video. So first of all, I know that this boiler is working. That's the first thing I want to know. It's running. So because I don't want it to overheat, I'm going to turn it off. But be careful when you turn appliances off, because when you shut them off from the power, they can cause problems and not come back on. And in this plant room, I can see that there's only one boiler. So there's more than one way I can turn a boiler off. I can just shut off the gas supply if I want, or I can go to the panel and turn it off. But sometimes when you switch it off from like the main isolator, I don't know if this has ever happened to you before, but you've turned it back on and the surge in power can stop the boiler from working. So let's go over to the BMS panel. And on the way there, we can also check the temperatures that we have here. So you can look up here and see, I see that gauge is dancing, but I can also look for temperatures that I've got in my plant room. So say for instance, I'm servicing a lot of boilers, I may see the temperature decline if I'm here for a while, like doing a full strip down. So what I'm going to do is shut the boiler from off on the panel. And also sometimes when you do that, you can look to see which relay is responsible. Can you see? Down here, this relay looks like the relay for the boiler. Relay 3, and then up here, you see these two here look like they're also, at the moment they're on auto, but there's a way of putting them onto hand, the jumpers. Can you see them? Let me turn the light on for you. So sometimes in these panels you get, before I go back to the boiler, you get parts that are low voltage, like on this side for example, there can be low voltage areas, and they like to separate it in control panels, low voltage and high voltage often. So over here, but look on the panel. So for instance, on this panel here, where are we? It's telling me 240 volts. So you know that's what you're going to get roughly. Whereas in certain panels, you'll get 410 volts. So look for that so that you know what you're dealing with. And also remember, safety mat, look for the safety mat. And so just be careful. You don't always have to have things like rings, metallic rings on when if your hands are getting in here. Be careful. All right, so we've turned the boilers off. Let's see if it goes off on the panel. That doesn't always control it, but I have a funny feeling it will in this case. Why am I turning my boilers off? Obviously because I don't want the heat to the boiler to get too hot. But later we're going to turn up our temperature anyway, our flow set point, so that the boiler stays on for longer. So in this boiler here, you've probably got a switch live as well from that panel. It's probably a switch live coming over here. It's got switch live here, but it's like more than likely a 0 to 10 volt inside here signal for it to come on. And depending on the 0 to 10 volts, the boiler, it's either to do with it will get the boiler to likely do like output of 100%, or it will tell the boiler, depending on the voltage it gets of 0 to 10, operate at this percentage based upon the voltage that you're receiving. So before we start, the boiler's gone off. It's just fans running to get rid of the exhaust fumes. So have a look at the condition. These AAVs on these boilers like to be in this condition a lot. I don't know why. Maybe some error, but I often see this. Other signs of dripping I saw was I can see a little splash point there. Can you see it? That splash point on this particular unit. So, and I think it's creating corrosion down here. So I'll mark it up. I'm not here for that, but I can see here on the unit there's a bit of corrosion. I think it's from a leak from up here. So potentially from here or here, or maybe up here from this, what looks like a low loss header. What is it? Low velocity header it's called. It's quite tiny. Have you seen these before? And then we've got PRV here. Always get the look for to see if they're within 5 years. It tends to be 5 years that the insurers want them to be changed every 5 years. I haven't seen a PRV like this one before. It looks a bit weird. So okay, back to the boiler. This is a Keston boiler. Watch out for these flues because often they're made of the wrong material. So you need to look up here, and then in the book they've got what type of material they want their flue to be made of. Yeah, so you have to go up and check. And other things you need to do as well on the flue, make sure they're obviously clipped. So we haven't even started servicing yet, we're just looking. And look if there's movement. Look if there's movement on your flue and how clipped they are. And also you want to fall on them. You don't want them just level, you want them to actually be falling back to the boiler, a decline. So over there it looks like it's got a fall. Yep, that looks good. I think that's reasonable. And then you want to see it terminating on the outside as well. You want to see that the termination is good, and according to, let's go back down from this ladder, according to what the manufacturers say. So let's have a look in this book. So the manufacturers stipulate how they want it to terminate, how far it's allowed to be as well with the runs. This book is in a bit of a condition, but look, it tells you how they want their flues. They've got a lot to say about their flues here. See, it gives you an idea, do you see? So when I go outside, I can have a look to see, is my flue like that when it goes outside? And also they tell you how many bends it's allowed. So take that into account. Not just this flue, but any flue. Look how many bends there are and how many are allowed. That's something that's often missed. Then my pipework, whilst I'm here, I can look. Is my pipework undersized? Look at the size of this. I'm not sure what size pipework this is, but it drops right down here into 22 mil. So I need to check my pipework. So here's my pipe. So for instance, look at my gas pipe. So it's here, there's a clip on it. So much movement here, there's a clip up there, and then all of a sudden it goes from here to there. It would have been nice if they just threw a little clip around it there, but they didn't. Never mind. There's not much movement on it. And it comes over to here, solenoid. Not every plant room has a solenoid. Don't knock yourself out if it doesn't, okay? Main thing is that they have a isolation valve. Plant rooms need to have an isolation valve, but in line, I believe, with the insurance and so on, some plant rooms like to have these so that in the case of a fire, they shut off. I've seen plant rooms where these do not actually shut off the gas when the fire alarm goes off or when the knock-off button goes off, which is quite strange, but 9 out of 10 times they do shut off when there's a fire alarm or when the safety knock-off. Let's see where the safety knock-off in this plant room is. Here it is over here. The safety knock-off when it's activated. Okay, back to the boiler. All right, so we looked at our gas supply. We're going to check that in a moment to see when we're working at high fire, how much gas it's pulling. That's very important because we may not be able to carry out a gas rate, but at least in 9 out of 10 scenarios, we want to check the working pressure up here on the boiler to see if our gas supply is adequate. If I had more boilers here, ideally I want to have all 3 of them on in high fire to see how much gas they're pulling. Inside here, I don't know where my meter is. It looks like it's going through the wall here. I'm not sure if this has been sleeved. It may have been sleeved as it's going through and so on, but I'd like to see the gas supply on the other side. Also, I want to make sure I've got earthing on my pipe and that it's identified with gas tape and so on, yellow, etc. Okay, back to the boiler. So now the boiler's off and it's cooling down. What we're going to do, this boiler here, no seal kit was ordered on this particular one, so I can't break into here and see what's going on in here, but I am going to check to see what my combustion is like, and I can look for any signs in the boiler of problems. There's no problems that I can obviously see. I can also check the previous readings to see what the other person got and so on, so I can have a look on there. My analyzer's ready. Are there any plug points in this plant room? So I need to think ahead and look. Hold on a second. Do I have plug points in my plant room? I've got a drain here just in case I was doing any sort of drain line work. It's good to take that in for future reference. But look, There's plug points here. You might look at this and think, oh wow, what's the big deal? Trust me, when your analyzer's dying and if you haven't charged it, that is quite a big deal. All right, so, and also I need to know that I've got pumps running. So when I get my boilers working later, I want to make sure that these pumps are operating. Otherwise, the boiler's going to overheat. So I'm getting it to cool down now. Have you seen these pumps before? Never seen this type of, what is this here? Not sure what this is. This thing on top of the pump, can't really quite work out what this is. It's coming out of this little storage tank here, but I don't know, I've not seen these pumps before. It's quite interesting. Tell me what you think about it. There's two pumps here. I don't even know what they're doing, these pumps, and they've got some form of solenoids on them. Yeah, interesting. All right, and then more up here. So as it comes off, it goes here, and then washroom jet. Yeah, I've not seen this before. I find that quite interesting. All right, back to our boiler. So back to the boiler now. So we want to do our combustion readings and we want to do our working pressure. We can do it at the same time. Ideally, you want to do these in high, fire, and then low. Make sure you've got your manual either on the phone or nearby to refer to. Also, it's good to have a look at the condensate trap to see, does it need clearing out? Is it fine? Ideally, you should clear it out, look for a drain, and then replenish the water. Okay, if the condition of it is great, you don't need to go and play with it, because when these get stuck, sometimes these balls, or they get in a funny place, it can become a nightmare. But just check your condensate trap, it's not overflowing, it's not blocked, and clear it if necessary, especially if the manufacturers stipulate that it needs cleaning. All right, so always remember with the working pressure, normally the working pressure is going to be on the incoming of the gas supply. So I see the gas supply coming in here on the boiler, it comes up to here, so this is where it's going to be my working pressure. Normally on this particular zero governor, I cannot check the burner pressure, but on other boilers, not this particular type of gas valve, but on others, you'd be able to check a working pressure, and that's normally after the first point on the other side, nearer the other side of the gas valve, or after the working point. Hopefully you get my drift. Okay, and then these probes here, ideally you want to change them on a service, but if you haven't got the service kit, you can't change them. But in certain scenarios, if you've got some of these gaskets here, or they're in good condition, you can clean the probes up, especially if you come on a call out and the boiler's not lighting. There's nothing wrong with taking these out, so long as the gasket is okay underneath, and you clean up the probes, check their distance and the detection, so spark and detection, make sure that they're in good condition, and the boiler is likely to light, because these are the most likely things to go often on a boiler when they're not changed. But I personally think that you should have spares, especially when you've got one boiler on a site like this. I think you should have spare, like up here on top of the boiler. It'd be good to have a spare set of probes. Okay, these, you've got to be careful with these, especially these. They can get lost on this particular boiler. It's very small, and these can actually crack as well due to the design. Where are we now? Time to service. I'm going to get to the test point here, on the right rather, and check my working pressure. Okay, I've got my I'm going to turn off my gas supply. Yep, so I can turn it off here, or I can turn it off here, or I could go all the way over here and turn it off here. So what I'm going to do is I'm going to turn it off here, and so I'm going to do a local tightness test. Okay, so it's come to the boiler, and the boiler's got no demand and it's not coming on, so that's good for me. So I'm going to, whilst I attach my gauge, I've got the gas supply shut off, so I'm going to attach my gauge, so there's going to be less gas coming into here. But when you're letting gas into a room, be careful, because if it's in a public dwelling, they're going to smell gas and they're going to probably panic. So you don't want there to be too much. Make sure the place has got ventilation. Always keep your eyes open. Okay, look for things. Look for the fire alarm, because you see if the fire alarm, look, thermal link, that's there. But you know, if this was over here and I've got this open, or even for a moment, the fumes can go up and beep, 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 beep. So keep an eye for that. Someone's left some electrical tape up there. I may use that in a moment, just when have your tape ready, like your electrical tape and things like that. But this, if that's usable, I'll use it to tape my readings to the boiler. Okay, sometimes you got to look for little shortcuts when you're doing your work. All right, so gonna get our test gate. I'm gonna put the phone down for a moment to do this. First, so I want to turn my manometer on. I want to make sure it's zeroed. I'm going to just zero it. I want to make sure I've got millibars. Lovely. Put that somewhere. And make sure it's not kinked. Okay, so there was enough gas in my system, okay, to get to, so when I attached it, I didn't need to top it up much, but I can tweak it because I should be on 20 or 21 millibar for this. Even when you're doing local, so you carry out your volume calculation and then work out what you're allowed. Okay, so we're going to leave our gauge on. We're not going to go and take it off now and then put it back on, take off. It's on. So that's why when we're going to do our first tests. All right, so I'm going to re-establish the gas supply. So I'm coming back over here. Okay, now I've got standing pressure. Okay, and then now I'm going to turn my boiler on. I'm going to get my analyzer ready as well. Okay, so my analyzer is off at the moment. No need for it to be on. I could also get my gauge in here for my pressure, so it prints out. Okay, and then now I'm going to take the temperature up on my boiler. Let's see if we can do that. So the first step, I'm going to enter, or select rather, and we're going to, remember it was 68, so I'm going to write that down somewhere, okay? I found it on 68C. Okay, so that's what I found it on, and I'm going to try and bring it back to that later. So for testing purposes, I'm going to put it to the maximum. Select, let's make sure, no, it hasn't. So I need to put enter on this particular boiler. So that stays. Let's check that is, yep, it's registered. All right, so that's that. And then now we need to get into service mode. Summer, winter, select. We're going to do maximum first. Always do maximum, high fire first, and then low fire. Hit enter. I'm going to go back to my boiler, well not my boiler, my BMS, and create a demand, just in case that isn't enough over there. And put it to auto. Sometimes you can put it to hand. So my relays have kicked in, and so is my other one. If it doesn't, I can force it. I can put this on hand over here, the two that are on, and I could put this on hand by flicking it up. So I'm back now to my boiler. And I'm going to check my working pressure now on high fire. I'm going to turn my printer on. Okay. And I want it to stay on for quite a while. Here's my working pressure. Yep, so I'm going to get a picture of that or write it down that in high fire, that's my working pressure. Burner's on, give it a chance to my flue to get up to temperature. I want to see my CO2, check inside the manufacturer's instructions what it should be. But I believe on this particular unit, you can't adjust the gas valve, or that it's not recommended, I believe, on this particular unit. So I'm going to look for my CO2, wait for my flue temperature to stabilize, and then I'm going to print it in high fire. I can write down, if you've got a certain, I can write it straight down in here in my service book, or my service sheet, my working pressure. So I know I've got 20.8. So even here, I could write 20.8 millibar. I could do the kilowatts later if I want to, but what's this asking me for? It's asking for millibar or kilowatt. Okay, so that's there. Has it stabilized? Okay, remember we don't want this to overheat and then cut out. So sometimes we could do two printouts. We can print one, and then we could leave it on for a while and then print another one if we so choose, when the temperature of the flue's gone higher, but we want to do it before it cuts out. If I hit select here now, I could go to minimum and press enter. And then I should see a difference in my working pressure. My working pressure should be different when I'm in low fire. And even my combustion, eventually my flue temperature, even though it's at 63 here, it should drop. My flue temperature should drop a little. So it's at 63 there, but it should go down. My fan is ramping down in speed as well. See my working pressure? I've got the burner still on, but the working pressure has changed. And that flue temperature, T1, is my flue temperature. It should start dropping. You see TA is temperature ambient. So that is my temperature in the room. That should be, remember to check your high, your mid, and your low position and make sure it's correct. So my flue temperature has started to drop. My CO2 looks good. So I'm printing out my second reading. Okay. So we've got our boiler on. We can reset our boiler. And I'm going to do a safe. So we're going to wait for him to try and come back on or getting ready to light. So I've reset him, but he should be getting ready to light in a moment. I'm going to select a setting, maximum for example. Select. He's starting to get ready to start up. My fan's running. Going to do my safety. My safety shut off. That's a bit tight. My safety shut off time, so I can do my countdown of my 1, my 2, my 3, my 4, and I can time how long it takes for the boiler to shut down, the safety shutdown time when the gas supply is interrupted. That's another check you can do. So it's not lighting because the gas supply has been shut. So how long is it going to take? How long is it going to take? You can clearly see the gas valve open there because the pressure dropped. That's a good test for checking that your gas valve is working. Another test you can do is you can check the resistance. I believe on this one it's the 2 outer pins, but you can check the resistance on it and what it should be. So it's doing its attempt to light here, and I should be counting how long it takes for the safety shutdown for it to go into lockout. You can check with the manufacturer the time if it's correct. Okay, well, whilst that's doing that, I can start continuing in my paperwork. So safety devices, correct operation. So that's one of the checks we're currently doing at the moment. I'm going to say yes. Ventilation. So this is a room sealed boiler because room sealed, it means it's taking its combustion air from outside. Okay, it doesn't mean anything else to do if it's been sealed or this or that. People get confused about what room sealed means. Open flued means it's taking air from the plant room. So if it was open flued, this particular boiler, I would really want to see some good ventilation inside here. I don't see any proper ventilation, purpose provided ventilation for this plant room inside here at all. Okay, so this is a room sealed appliance, so it should still have ventilation, but nowhere near as much as an open fluid appliance. What else am I doing? Before I even write anything else down, I can look down here to see if I see any more errors. So ventilation adequate, I would say yes. Okay, visual condition of chimney. So I've only seen inside, yeah, I haven't seen outside yet. In order for me to tick this box here, I should go outside, because for all I know, when that goes through there, it could be damaged, broken, and I'm gonna say it's fine, and I've got to fill out another sheet or a warning notice. Okay, that's it terminating. Okay, I'm happy that that's fine. Hold on a second, let's see if what's happened with this boiler here. Normal operation. Has this boiler cut out yet? Yep, it has. See? So it's locked out. All right, so make sure that you time that and that takes place. So our visual condition of our chimney is satisfactory. Yes. All right, performance pass. Gonna check our combustion readings. Okay. So we want to make sure that these are fine. So let's go and have a look. So good. Yeah. And then we want to write on here high and low. Now what we're going to do, be careful. You see, I just popped outside for a moment, but just be careful when you leave anything like this attached. But as you may notice, I walked outside and it was isolated. The gas supply was isolated, but remember to put these back, okay, these gauges. So whilst my gas supply is isolated, I'm going to close this, and then you want to put leak detection fluid here, or you can even use your gas sniffer to connect it to here. Okay, you can put a gas sniffer here if you don't want to use leak detection fluid. Okay, well done. Okay, we're going to open up our gas supply again now. This handle's quite stiff, but it's functionable. All right, so we're going to hit our reset button on our boiler in a moment. And our combustion readings, we want to write on here, for instance, like our high, I know you see this particular sheet here doesn't ask me for the time of my safety shutoff, but some sheets will say how long did it take for the safety shutoff to take place. Did it take 130 seconds and so on, or you know what I mean? So bear that in mind. Not every sheet is the same. And then here I'm going to write on this particular sheet, it wants to know initial and so on, but I'm going to write high and low. So my high on here as well, I can put the name of the customer. I can say boiler such and such, and I can say high and low. You understand? Okay. So where are we now? So on here I'm going to put my readings down. So my high fire took place first, and I've got my readings here, my 0.0003, so I'm going to put that here. On different sheets, this is a CP17. On a CP15 I would write more readings down, more combustion readings than this, but this is a CP17. Is the appliance safe? Yes. And then I can write down here that on the next service kits should be provided. Okay, something I should have done before I done this is I should have, whilst the boiler was off, I could have done this, but it's okay to do it now. But it's just nice and better if the boiler is off when I do this. Because for instance, you could get a lot of heat from here, a significant amount of heat, and that could come up here and probably set off the thermal leak. Alright, my analyzer as well needs purging, and then I can turn this off as well. Don't want to waste the battery. And then my printer as well, saves the battery life. Okay, my boiler, now I need to go back to it, set my temperature back to what it was. So remember what we had here, what did we write down? 68. And then we have to press enter. Yep, 68, great. Okay, I'm gonna go back over here to my BMS and make sure it is on auto. Auto, lovely. Back to auto. Alright, and then we continue filling out our sheet. We can start getting quick now, so we just go bam, bam, there's no more appliances. Don't leave any boxes open, and then warning notice attached, no, not applicable, not applicable. And then I carried out a local tightness test. I can have a look at the meter. And then I'm going to carry out, I'm going to say here, service of gas boiler and local tightness test carried out. Alright, not going to leave anything blank. I'm going to say service kit required on next visit. That's it. And then I'm going to blank these out. Not applicable, so we need to make sure that everything is filled in. Alright, here I'm going to tick this box here. Remember, there's a lot of different service sheets out there. Okay, the meter, I can have a visual inspection of the meter, but in this particular job they've not asked me, nor have they paid for us to check the gas meter. So I'm going to have a quick look at it outside, and then I'm going to fulfill this part of it, but make sure that everything's filled out. This bit here as well, you need to put the details. So we can put plant room here. Make sure there's only one plant room. Check the previous cert that the other engineer carried out on site. You can get that information, get it from your company, just in case you get snookered. And there's another appliance on site. Appliance, gas, boiler, make, and then the make is Keston. And then the model is a Heat 55. Heat 55, and it is room sealed. Appliance checked, yes. Number of appliances, 1. And then I just put all the details up here, and then I make sure everything is ticked and so on, every box. All right, a few other things we should check. So there's not always a drawing of things like this, but when you see it, have a good look at it. And then this is another drawing of the plant room. You see, do not take these for granted. Get pictures of them because they can go missing and so on. It gives you a good layout of what's happening in the place. So just make sure all of these are back on and home. Before you put the case back on any boiler, always have a look to see if you see any signs of leaking, spillage or anything like that. Okay, so we've got the case back on the boiler. Make sure that it's sealed and so on and safe. Lovely. And I want to put down the serial number in a moment of my particular boiler. Actually, there's not even any space for it here, but I'm going to, on another sheet, write the serial number down. Okay, that's good to put down. I've seen people miss them, but don't miss the serial number. You need to, the boiler wants good identification. There's a magnet clean here. I haven't been asked to do it in this job, so I'm not going to isolate it, because what if you can do it and want to be a hero, and then you undo it and then it starts leaking. You have to seal it, and then you're there for more than what you attended. So this could even be put down on the notes that you need to go back and clean the magnet clean out, unless it's being paid for by the client already. And then the PRV as well, get details of the PRV, because I don't see any particular date on this PRV, and there should be a date for it. See how it's discharging. Where is it discharging to? Down here, there's a drain over there. It's not the end of the world. Expansion vessel, give it a little knock. This one looks in a bit of a bad condition. There's a bit of air in there, but to do it properly we have to isolate here. I don't know where that's going over there, but likely, where's that going? I don't know what that is all about. Okay, so this is connected to here. No, I don't think I've seen that before. I've seen these, but I didn't realize it went in here in the pipe, and then it tells you low pressure, high pressure, and so on. So you'd want to isolate that, drain it down, repressurize it, and so on. But this vessel here looks like it's due for change. So you could mention this, you could mention that. Around here, there's a dosing pot, but how often do these get changed? They got pumps here. Whilst you're there, there's nothing wrong with switching the pumps over to see if they're operating. That doesn't hurt. And then whilst you're there as well, this is an actuator for the heating. You could even get your multimeter out and check to see if this is operating properly according to the signals it's receiving. There's a strainer here. You could also book up that the strainer should be cleaned, and make sure that there's gaskets for it to be changed. I think I saw a strainer over here as well. Look, there's a strainer on this side that also could be cleaned out as well, but this also needs to be booked up in terms of gaskets and so on. This here now, this valve looks like it needs, like it's should I say, a particular number is on it. So can you see the numbers? I don't see the numbers on it. Let's have a look. Or is that for it to be adjusted? Oh, here we go. Can you see the numbers? So it's good to put them back to their numbers. Where did I drop that little thing? Need to put that back on there. The little sight glass. Pop that back on here. All right, put that back in its place. Lovely, that's back there. All right, and then back to this panel. What is this for? AHU fan speed. Okay, I've not seen these controllers before. Those look good. So remember, what I'm basically saying is when you go in a plant room, although you have to go and do your bits on the particular boiler, at the same time, do a little recce and learn something quickly whilst you can. Like, be careful. But inside this panel here, you've got all the fuses. Let me turn the light on for you. So you've got the fuses here. Sometimes they're spare fuses. You see they've put some down there, 10 amp fuses for when these pop. It's good to have them. And then these are the contactors. Okay, and then you've got your trend IQ4E there. All right, your inputs and your outputs, you see the arrows? The arrows are telling you whether they're inputs or outputs. Can you see? Can you see the inputs here going in and then the outputs going out? Do you see? Good, good, good. All right, what else have we got here? Transformer. Okay, lovely, lovely, lovely. So if you are capable with a multimeter and you are safe to do so, competent to do so, you can check. This is funny because the thing said single phase, but I'm seeing 3 phase here. I see 1, 2, 3, and I'm seeing 3 phases here, even though the board told me that it was only single phase. I'm seeing what looks like 3 phase to me. Okay. All right, sometimes you see the wiring diagrams as well inside here. Okay, so I'm going to finish all my paperwork, make sure the boiler is how I left it, and then I'm going to get all my paperwork written up and sent back, and everything's done before I leave this particular site. Any extra details such as clean the magnet clean, doing this as well, that has to be done on another job because I only have a certain amount of time on this particular service because I have more jobs lined up. But I hope that has helped you to understand about this. I'm going to also go and check the you see this condensate trap here? Look out for this. So that's got a trap on it. They've built that into it. It's not too bad here. I'm not sure where that's going, but I'm going to look at the meter when I go outside as well to have a look to see if it's conditioned, that it's locked and all of that. But that isn't what I'm here for. I was here to do a local one on the gas, and I could see that a clip would be good up there in the middle, going from there to there. But that's pretty. I could give a little nudge on it, but that looks pretty solid up there. All right. Thank you for joining me. Until next time. Bye bye bye.